All you need to know about reinforced cement concrete structures. Concrete frame structures are a very common, or perhaps the most common type of modern building internationally. As the name suggests, this type of building consists of a frame or skeleton of concrete. Horizontal members of this frame are called beams, and vertical members are called columns. Humans walk on flat planes of concrete called slabs. Of these, the column is the most important, as it is the primary load-carrying element of the building. If you damage a beam or slab in a building, this will affect only one floor, but damage to a column could bring down the entire building. When we say concrete in the building trade, we actually mean reinforced concrete. Its full name is reinforced cement concrete, or RCC. RCC is concrete that contains steel bars, called reinforcement bars, or rebars. This combination works very well, as concrete is very strong in compression while steel is very strong in tension. To make reinforced concrete, one first makes a mold, called formwork. This will contain the liquid concrete and give it the form and shape we need. Then one looks at the structural engineer's drawings and places in the steel reinforcement bars, and ties them in place using binding wires. The tied steel is called a reinforcement cage, because it is shaped like one. Once the steel is in place, one can start to prepare the concrete by mixing cement, sand, stone chips in a range of sizes, and water in a cement mixer, and pouring in the liquid concrete into the formwork till exactly the right level is reached. The concrete will become hard in a matter of hours, but takes a month, that is, 28 days, to reach its full strength. During this time the concrete must be cured, or supplied with water on its surface, which it needs for the chemical reactions within to proceed properly. Working out the exact recipe, or proportions of each ingredient is a science in itself. It is called concrete mix design. A good mix designer will start with the properties that are desired in the mix, then take many factors into account, and work out a detailed mix design. At SpecDeck Constructions, we often order a different types of mix for different purposes. For example, in casting a thin concrete wall in a hard-to-reach area, we design a mix that is more flowable than stiff. This will allow the liquid concrete to flow by gravity into every corner of the formwork. For most construction applications, however, a standard mix is used. Common examples of standard mixes are M20, M30, M40 concrete. The number refers to the strength of the concrete in N per square millimeter or newtons per square millimeter. Therefore M30 concrete will have a compressive strength of 30 N per square millimeter after 28 days. So the RCC structure is actually a connected frame of members, each of which are firmly connected to each other. This frame becomes very strong, and must resist the various loads that act on a building during its life. These loads include, 1. Dead loads, the downwards force on the building coming from the weight of the building itself, including the structural elements, walls, facades, and the like. 2. Live loads, the downwards force on the building coming from the expected weight of the occupants and their possessions, which include furniture, books, and so on. Normally these loads are specified in building codes and structural engineers must design buildings to carry these or even greater loads. These loads will vary with the use of the space, for example, whether it is residential, office, industrial to name a few. It is common for codes to require live loads for residential to be a minimum of about 200 kg per square meter, offices to be 250 kg per square meter, and industrial to be 1000 kg per square meter, which is the same as 1 T per square meter. These live loads are sometimes called imposed loads. 3. Dynamic loads, these occur commonly in bridges and similar infrastructure, and are the loads created by traffic, including braking and accelerating loads. 4. Wind loads, this is a very important design factor, especially for tall buildings, or buildings with large surface area. 5. Earthquake loads, in an earthquake, the ground vigorously shakes the building both horizontally and vertically. This can cause the building to fall apart. The heavier the building, the greater the force on it. The concrete frame rests on foundations, which finally transfer the forces, from the building and on the building, to the ground. At Spectacle Designers and Constructions, safety and client satisfaction is our priority. Contact us at www.specdeck.com for all your RCC designs. Hope you found this video helpful. Thank you for watching.